5. Okay, so number 5. All right, yes, number 5. That was the first one that the last class asked about. Okay. All right, so this is inequality. Given that B is greater than C, there are two main ways that I would approach this problem. Okay. One would be to try to solve or simplify it algebraically. All right. Solve or simplify algebraically first. 2, the second thing I would do is substitute in values for B and C. And make sure that B is a larger value than C. And by putting real numbers in, you're going to find out whether it's true or false. Okay? I'm probably going to focus more on the algebraic part. And then, because I feel like you can substitute numbers in and see if that's going to work. Right, Damari? Okay. So if I have, for the first one, are we looking at A, B, C, and D, Isaiah? All of them, probably? Okay. So if I am looking at letter A, which is B plus C is greater than 2C, what do both sides of that inequality have in common? C. And if they are common to both, I want to try to take away what is common and see what I have that's left. So mathematically, how would I get rid of that? Amani, are you with me? Subtract what? Yeah, subtract C, subtract C. C's over here are going to cancel out. 2C minus C. You're not getting rid of all the C's because there is a 1 understood here. So if you have algebraic questions, it's like 2 cats minus 1 cat. You still have 1 cat. Think of it that way. Okay? So you're saying B is greater than 1C, which is still just C. That's the end result when you take the same thing away from both. And B is greater than C is what we started out and are given, so that means that this is true. So justifying it, I would say by subtracting the same amount from both sides. Okay, you get B, which is greater than C, which was given. Okay? Yeah.
So the way that I did it was like,
Uh-huh. Uh-huh. Okay. That would result in 3 being greater than C. Mm-hmm. Yep. And did you describe that somewhat when you said justify? Okay, you do need a sentence because you're going to have problems like this, and each one is going to be worth 2 points. One for either correctly choosing true or false, and then you have to explain why. So just make sure you explain how you figured that out. But yes, you can do that. Okay? All right, any questions about A? B.
Did that say same amount?
Yes, AMT, I abbreviated. The next one, I have 472 minus B is less than 472 minus C. So here again, I see the same amount on both sides. What could I do to get rid of that same amount? Again, I'm doing this algebraically. Yeah, subtract. So subtract 472, subtract 472. And you get the opposite of B is less than the opposite of C. Okay, but We don't know that yet. What else could I do to these to get them to be comparing B and C?
You can subtract 472 with like different numbers for like adding substituting B and C.
I don't think I want to add,
No,
but this is a
no.
negative.
Yeah, I meant that's not adding. Like when you're substituting B and C, you're subtracting 472.
Oh, I thought you said something about adding.
No.
I want to change these negative values to be a positive. How could I do that mathematically? I could multiply by -1 or I could divide by -1, right? And either way, if I divide by -1, I divide by -1, we get B, and over here we get C, but what happens to, yeah, you got to flip the sign. When you multiply or divide by that -1, you flip the sign and you get B is greater than C. That's what we were given, right? So is that true or false? That also is true. Okay? So you would justify it by, subtracting 472 from both sides and what? Dividing by -1 gives you B is greater than C, which was given. Something like that. Okay? But again, if you substitute a value in, if you take away a larger piece of, let's say you have two pies that are pretty much exactly the same. If you take away a larger piece from one pie and a smaller piece from the other, okay, the side where you took away the smaller piece is going to be bigger. Yes. 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 I'm going to get you a pass. Questions on that? All right. In a similar way, what could I do for, what number is this? 5C. What is common to both of those in C? C. And what is happening with C? It is now being added, subtracted, multiplied, divided. It's being squared, which means it's being multiplied. So to undo that bond of multiplication, I should divide. So if you divide by C and divide by C, you're left with, remember, this is kind of like exponents. C squared divided by C, you're going to subtract, and you get B is less than C. And what do you know about that? That's right. So is that true or false? That is false. And you, don't tell me. No. Kyla, right? 821. There you go. All right. So that is false. La-di-da-di-da. And you say, dividing by C. Leaves or gives B less than C, which is false. Not given and is false, or something like that. Okay? All right. Any questions about that last one? Okay, and then letter D, 1 over B, 1 divided by B, is greater than 1 divided by C. There's a couple ways you could do this. This you can substitute a number in and say 1/5. Would that be greater than 1/2? Okay. Maybe you don't even know that. You could find a common denominator and say my common denominator is 10 multiplied by 2 over 2 and 2/10. How does that compare to 5/10? Is 2/10 greater than 5/10? No, so that would be false. So in the same way, algebraically, if you have B and C are two different numbers, you could multiply the whole thing by BC, and the B's would cancel out, and you end up getting C is greater than B, which is also false. So there's many ways to do this, okay? And to justify, you can say substitute numbers for B and C, find a common denominator, and something like you will find it's false. So if you show me the work and you write about it a little bit, you will be covered. Find a common denominator and you see that 1 over B is greater than 1 over C, something like that. Or you can say multiply by that common denominator on both sides and you get the reverse. That's true. C is greater than B, which is not true. Okay? All right. So, any other questions on number 5? All right. What other questions? Got all this down? Javion?
Number 6.
Number 6.
Because I don't understand.
Number 6. Next page. Which of the expressions in the given pair is larger? Explain how you know. So based on what I just said before, what should you look for in this? Okay. Do we have anything that is the same or common to both sides? So what should I do with that? Subtract. So subtract s squared, subtract s squared. So that cancels that out, that cancels this out. So you're left with 6 and negative 3.
6 is larger.
6 is larger, yes. So which of those given expressions should have been larger to begin with?
6 is larger than.
Right, but which of the expressions? It should have been the s squared plus 6, the one with the 6, right? Because if you take away the same amount from both sides, then the side that has the leftover that's bigger, obviously is going to be bigger with the whatever you subtracted before. Okay, how do you know? Subtract same amount from both sides. So yeah, it's not just that you have to do the math, you do have to do a little explaining. Subtract the same amount from both sides, and the result is 6, which is greater than negative 3. So s squared plus 6 is bigger. Something like that. Okay?
Side.
Both sides of the inequality, yes. All right, what else?
Sides of
Sub-
side A.
subtract the same amount from both sides, and the result is 6 is greater than negative 3. So s squared plus 6 is bigger. 7? Okay. 7, all of them? Pretty much? Okay. Let's take a look at 7. Add twice a number to 3, then multiply the sum by 5. Okay? Gabe, you with me? Gabe, you with me? All right. What number should I use here? N. Let's use N for number. I like that. So, add twice a number. How do I show twice a number? 2. Okay, so what would be that expression? 2n, add twice a number to 3. Yeah, so you're going to say 2n plus 3. You added twice the number to 3, then multiplied the sum by 5. Parentheses around this, and I'm going to put the 5. I'm going to put it out front. If you put it behind, I won't count it wrong. It's the same idea, but usually we put it out in front. Okay? Excellent. And if you didn't get it right yet, you just, just a little bit here. Now, I need to show the area model. I need to draw a picture. This is the sketch that some of you were not doing the sketches in the homework for 1-3. When it says sketch, I'm looking for something like this, okay? So I want to show a rectangle that has a width of 5 and a, excuse me, length of 2n plus 3.
I think the rectangle is too big to put the numbers in the outline box.
Well, yeah, but we'll make it work. So the width of 5 goes over here.
You should draw the line in the middle of the box.
Okay, I'll get there. And then I want 2n plus 3. Now, what's that going to look like on top? Well, here's 1n. Here is another n. And here I'm going to have 3. Now, maybe some of you went ahead and said this is 2n, and maybe you did one rectangle. Hello, I can hardly hear myself. What are you guys doing? At least I know you're talking math, but okay. So if I put that together, if you were to look at this, yes, this is n. Yes, this is n. N plus n is 2n, and then this is 3. You can still put 2n. I would still take that. Now, if you do that, if you do it individually, 5 times n is 5n, 5 times n is 5n here, and 5 times 3 is 15. Or if you did this as one big rectangle right here, 5 times 2n, the 5n and 5n would be 10n. I probably should have done it that way.
Yeah.
Yeah.
You should have just put one box here, one box here.
Well, if you remember from the card sort, though, there was something that was like n, 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 n. So they didn't put 3n.
I don't like that.
You didn't like that? Okay. All right, so there's the first one. 15 plus 5n. If I'm going to do the drawing over to the right, what would I need to have as my width over here? What's the common width for both of these? 5. You're factoring out So if I could divide by 5, 5 is my common width. And that means on top, I would have a 3. And over here on top, I would have, because this is 15, this is 5n, I would have the n. Right? And to write it over on the left, how could you write this expression?
15 plus a number times 5.
Okay. So you could say a number times 5 or multiplied by 5. And then what'd you say? What'd you say after that? A number times 5 and then add 3 or plus, or yeah, not 3. And add 15.
I just swooped it.
That's fine. You said 5 times a number.
No, I did 15 add 5 multiplied by n. I don't know the word.
15.
Add 5, like plus 5.
Uh-huh.
And then multiply by n.
If you say 15 plus 5, then multiply by n,
Yeah.
I would think these two would be together.
Like add 5, like multiply.
What did you say specifically? Because it makes a difference.
I was trying to say like.
No, read to me what you wrote.
15 add 5. Then multiply by n, as in like.
Now wait, you said 15, add 5, then multiply by n?
Yeah.
If I take 15 and add 5, that's 20. And then if I multiply by n, I get 20n.
No,
So I would say, listen, I've heard what you said. I would say the way you have written it would be incorrect.
I was trying to say 15 plus 5 with like parentheses n. I was trying to say that, but I don't know how to say it.
Well, you should start probably with the 5 times n. And then say, and then add 15. Okay, yes.
So if I did multiply n by 5 and add 15, that would be right?
That's fine, yes. Because you're getting that multiplication done first, then add 5, yes. All right, any other questions on that? All right, let's take a look at the third one. What is the area of the first rectangle here? 2s. That's the first rectangle. What's the area of the second rectangle with a length of 3 and a width of 1? 3. So if I push those together, what is my expression, my numerical representation? 2s plus 3. 2s plus 3. And how could you verbally say that? I would say multiply 2 by s and add 3. Is that the only way you can say it? No, but you do have to be careful how you say these verbally, okay? All right, I see a lot of people on your phones. And I understand, maybe you have this done, maybe you get it. Do not take this first test lightly, okay? Do not take it lightly. All right? Yes. Yeah. 2 times the number. Yes, perfect. All right, the last one. This one is a little tricky for the area problem. if I have something squared, what is that shape going to be? It is going to be a square, which is, every square is still a rectangle, but I'm going to make it a little bigger here. And what is the length of each side? N plus 6. So here's the n amount. Here's the 6 amount. And then up on top, I'm going to have n and 6. So I'm going to, yes. So I'm going to draw this kind of like this. These two technically should look exactly the same because they are both 6n. You see that now. And this one up here would be n squared. And this one down here, 6 times 6, would be 36. And you're like, wait a minute, that is not over here at all. But if you distribute this and write it out as n plus 6 times n plus 6, and then distribute, you will get n squared plus 6n. And then if you distribute underneath, 6n plus 36, which gives you that total n squared plus 12n, which is both of these added together for like terms, plus 36. Ooh, the light bulb goes on. So how would you write this? How would you write this verbally to get this response? Yes, Janetta? Yep. You can say add 6 to n or 6 to some number and square the result. You can say take the sum. Sum means you're adding. You can take the sum of 6 and n and square the result. Any of those would work. Say it again. Yeah, that would work. Yep. All right.
Number 9.
Number 9.
That's right.
I'm sorry?
Why is there number 10 there?
Well, I guess different versions of practice reviews. I think if you look on the answer key has a few more problems on it that we have done in the past, and we decided we didn't need it.
So how many questions are in the test? Do you know?
Right off the top of my head,
Because you're like.
I want to say 4 or 5. It's 2 pages front and back, which I think is what this is.
So not a lot.
So number 9, is that what we said?
Yeah.
Order of operations. Order of operations.
Because I kind of just like put it in the calculator.
Okay. Which you can do that. Please excuse my dear Aunt Sally. Do you guys know that? Besides PEMDAS, do you do please excuse? Is it?
Yeah.
My middle name is June. Do you know what month I was born in?
June.
October.
Your middle name is June?
Yeah. I know. Sounds old, doesn't it? I am old. I am 72. I look really good for 72. I'm not 72. All right. Here we go. Come on back. Come on back. Wait a minute. Oh, 36. We got a little bit of time. All right. Parentheses. You need to do what's inside parentheses if you can. So I see this 9 minus 2. That gives me 7. I am going to rewrite everything else as it is. It is cumbersome, but it will probably most likely get you the correct answer. So then I have this result, which doesn't look like any of those. Okay, so then we go to the next one. Do I have any exponents? No, I don't have any parentheses with anything inside them that I can do. So we're done with those. Multiplication and division, remember, It's as you read, left to right. So first multiplication I see, and you still want to do the most inside part, is this 7 times 7.
Wait, what about 7 times 3? That's
Well, as I look from left to right, I see 7 times 7 first. So that's going to be 49 times 3 minus 4 plus 1. I'm leaving that all the same. The 2 in front and the 5 times all of that. Next up, I see the 49 times 3. That is 147 minus 4 in parentheses plus 1. In front of that, 2 plus. And that, I happen to see that exact expression here for D. So D is definitely that same thing. Did you get that one?
yes.
Nice. All right. Then I see this in parentheses. Addition and subtraction goes the same left to right. So it's 5 times 149 minus 4 plus 1. This is going to be 145 times 5 out front plus 1. 145 times 5 is going to be 725 plus 1, which gives you 726. And I don't think, this one definitely is not. I don't think any of the others are. I don't think so, because this is going to give you a -2. 2 minus 4 gives the -2, which is going to throw it off there. I am very surprised because we're almost out of time. Did we go over 4? Anybody? 4 is easy. 4 is easy if you know how to do it. But I don't know, did I? Yeah. Did we go over it? Okay. Rectangle, square, maybe because lots of people are asking. Okay, what was it? 8? 8. Must be at the bottom. Oh, factoring. Factoring. You have to find the greatest common factor and divide it out. So for 3x and 21, what is the greatest common factor? So I would divide by 3. I show the division by 3. You don't have to, but then that sets it up and says that's x plus 7. And then as you distribute, you should get your first answer back, which you do. So this is the answer, and this is how I check. What about 9x plus 21? Wait, what about 9? 9 goes into 9. It does too. But it doesn't go into 21 evenly. You're going to get a half. When you're looking at factors, you have to use whole numbers. So that is going to be 3, which leaves you 3x plus 7. And if you multiply it back, you get 9x plus 21. So you know you're right there. And what if your first value is negative? What do I need to do there? Make sure you factor out that negativity, right?
So, you know how you say that A is the answer is negative throws off?
How, like this? What are you talking about?
Like, on the back picture, it says
Test tomorrow. If you want a little more extra help, come in tonight after school or send me a message through Canvas.
So you know how you say this is not the answer because negative 2 things are off.
Mm-hmm.
So I kind of like just search up the answer the question solving.
You know what?
And
I think.
And I put like in pandas and like it shows me the answer to this one.
7 times 7 is 49. I think you're right. It didn't follow like this, but I think this does get you the same answer. So technically, you are correct. That is
And-
one that works.
And for the
Good for you.
And for the homework,
Yes.
this is the wrong one, but that's like the answer to this one.
3x squared plus 3xy. Ah, it is not.
It's not.
Look at it again.
3xy?
No. You tell me what you get when you distribute that right now. Just tell
2x
me.
squared plus 3x y minus 3.
No.
I'm looking at it.
I know, but you said the last term incorrectly. 3x squared plus
Negative 3x.
3xy.
Oh, negative 3x.
Ah.
Shoot!
Rectangle.
Yes. You're not able to say after? I just don't have a lot of time. You're looking at it as a rectangle plus 2. Okay, so for figure 1, it is 2 by 3 plus 2. Figure 2 is a 3 by 4 plus 2. No, I did not. Sorry. Figure 3 is a 4 by 5. So the side is always one more. This side is always one more than the figure number, and the top is always 2 more than the figure number. So for figure 22, it would be a 23 by 24 plus the 2 on the bottom. Oh, you did it like a square though. Okay, so for the square, it is, for figure 1, this is a 3 by 3 minus the figure number 1. For figure 2, 2 goes to 4, so it is a 4 by 4 minus the figure number. So for the 22nd figure, it would be 2 more than that, which would be 24 times 24 minus the figure number 22, which gives you this. And you do the same thing. Instead, pretend like n was your 22. How did you get to 24? You added 2, so n plus 2 times n plus 2 minus the figure number n. Okay? All right. Say that again.
Would it be like one with the squares are missing on the test?
There's definitely one with a visual pattern. Yes. I have 2 different versions of the test, so it depends on which one you get. Okay? Just see, what do you see, what do you observe, and I think you'll be all right. Okay? And did you look at the key and the answers? Okay, so check that too. That shows both ways. Okay?